it's Mrs. Woolhite here. We're in Chapter 10. We're closing it up with Lesson 12. We already know that we're going to do some problem solving, and it is something we have to know for 5th grade. I'm hoping at the end of today's lesson you'll be able to solve some word problems. But why, Mrs. Woolhite? Why are we spending time on this? Well, to meet those 5th grade standards, but also I want to give you some tools, some strategies for solving problems. What do you already know about making a whole number a fraction? Well, I can make a whole number like 5 turn into a fraction by putting it over 1. 5 over 1 has the same value as 5. 1 divided into 5 is 5 as a whole number. So I can write it either way. They both equal or have the value of 5. The same is true for 3. I can put it over 1. It's the same amount. And that's going to help us today. All right, today those steps that we've been working on all year when we do problem solving is we're going to, 1, understand the problem. What do we know? What do we need to find out? After we understand the problem, we can make a plan. Then put your plan in action to solve. Finally, is it reasonable? Does your answer make sense? So again, what is the problem saying? How can I solve it? What's my plan? Let's go ahead and try to solve, and then check your answer. See if it makes sense. Let's learn the strategy. Yahim visited an aquarium over the weekend and saw 35 species of fish. This was 1/5 the total number of species of fish. How many total species of fish are at the aquarium? Well, I know he saw 35 species altogether, and that's 1/5 of the total amount. They want to know what is the total amount of species of fish at the aquarium. Okay, so he went to the aquarium, he saw 35 species, and that's 1/5 the total. How many total species are there? All right, I got the problem. Now I need to figure out a plan. Well, if I know he saw 35, and that's 1 part out of 5, or 1/5, then I can multiply 35 times 5. If 35 is only 1 part, I can multiply by 5 to figure out what 5 parts are. 5 times 5 is 25. 5 times 3 is 15, 16, 17. So I solved step 3, and I believe the answer is 175 species of fish are at the aquarium. Let's see if it makes sense. Is it reasonable? Well, one way to check this is I know that he saw 35 species, and that should be 1/5. So if I take 175 and I divide it by 5, I should be able to see how much is 1 part out of 5. Well, 5 times 3, 15. There's 25 left. Oh, it is correct because I did get 35. There are 175 species of fish at the aquarium. All right, I'm going to practice the strategy. Victor has $18 in a piggy bank. He spends 2/3 of the money on a video game and 1/6 on candy. How much money will Victor have left? Well, what do I know? I know that he has $18, and I know that he spent 2/3 and 1/6. So if I combine these two, I should know how much he spent. Okay, so my plan is to figure out how much did Victor spend, and then I can subtract that from the 18. If I know he spent $10 and I subtract it, I'll know how much he has left in his piggy bank. Well, I can't add these two fractions because they're not like fractions. So I'm going to go ahead and start to solve. And the first thing I need to do in order to solve this problem is I need to go ahead and create like fractions, and I'm going to use 6 as the denominator. 6 times 1, I'm going to do the same to the top. 3 times 2, I'm going to do the same to the top. So I can now add because I have like fractions. So I know that Victor spent 5 parts out of 6. Okay, well my plan was figure out how much he spent. Okay, well I know that Victor spent 5/6 of $18. Okay, so now I need to figure out how much is that. So my first part of my plan was figure out how much money he spent. Well, he spent 5/6 of 18. So now I got to figure out what is that. So I can go ahead and multiply 5/6 times 18 over 1. Let's see what I get. I got to figure out what's 18 times 5. Okay, well 18 times 5 is equal to 90. And now I got to figure out what's 6 times 1. Well, that's 6. I still need to continue to simplify. I have an improper fraction. 6 will divide into 9 one time, with 3 left over that don't fit in that group. Bring down the 0. 6 goes into 30 5 times, so 15 is equal to 5/6. Okay, so now I'm going to go back to my problem. I need to figure out how much money does Victor have left. Well, I know that he has spent $15 out of his piggy bank. So I'm going to go ahead and take 18 and subtract the money he spent on candy and a video game. And I think I have an answer. I concluded the answer is $3. It's reasonable because $3 is what is left in his piggy bank. Okay, if I multiply $3 times the total amount, which was 6 parts, 3 times 6 does equal the $18. So it makes sense that he has $3 left. All right, let's go ahead and apply the strategy. Mrs. Valles purchased sand toys that were originally $20. She received 1/4 off of the total price. How much did she save? Well, I need to figure out how much she saved. What do I know? I know that she had $20. That was the cost of the toys, $20. And then I also know that she got 1/4 of that amount off. So I need to figure out 1/4 of $20. All right, well, I think I have a plan. I think I'm going to go ahead and multiply 1/4 times 20 over 1. And if I multiply, 1 times 20 is 20, 4 times 1 is 4. So I can go ahead and create a mixed number. I have to go ahead and simplify this improper fraction. 4 divides into 20 5 times. So I think that she saved $5. Can I see if it's reasonable? Well, it says she has 1/4 off of the total price. So if I have $5 and I times that by 4, it does make sense because it equals $20, the old cost of the toys. So she did save one part, which is $5 off the toys. It makes sense. All right, solve the problem. Jacinda is decorating cookies for a class party. She can decorate 2/3 of a cookie per minute. At this rate, how many cookies can she decorate in 15 minutes? Okay, well, they want to know how many cookies she can decorate in 15 minutes. What do I know? Well, she can do 2/3 of one cookie in a minute. So 2/3 of 15 is equal to something. All right, well, I can go ahead and try to put my plan in action. My plan is to multiply. So I can go ahead and make 15 turn into an improper fraction with the same value. And 15 times 2 is 30. 3 times 1 is 3. I have to simplify my improper fraction. How many times does 3 divide into 30? Well, 3 divides into 30 10 times. So I believe the answer, I theorize the answer is 10. Is it reasonable? Well, it says it's 2/3 of a cookie per minute. How many cookies can she decorate in 15 minutes? Well, it makes sense that she would decorate 10 cookies, and so I know I have the right answer. I wish I could have one of her cookies. All right, Bobcat's still working on that problem solving. At a bird sanctuary, Ricky counted 80 birds. Of the birds he counted, 1/4 were baby birds. If he counted an equal number of adult males and females, how many adult female birds did Ricky count? So I need to know how many female birds he counted. Okay, I understand that. I also know there was a total of 80, and they want to know how many out of the 80 were female. Well, 1/4 of 80 are babies. So my plan is to figure out how many of the 80 were little babies, and then I can take that away to figure out how many are left, how many are adults. So let's start there. I can go ahead and change it to times, make 80 an improper fraction. 80 times 1, 80. 4 times 1 is 4. I can now make that improper fraction a whole number. 4 divides into 8 2 times. 4 divides into 0 0 times. So you can think of it as 4 goes into 80, 20. So I know that out of the 80, 1/4 of the 80 were babies. And I just figured out that 20 are babies, or 1/4 is equal to 20. So 80 birds minus the 20 baby birds, gives me 60 left. I have 60 birds that are not babies. But it's not asking how many are not babies. It wants to know how many of the 60 are female. Well, I also notice it says an equal number of adult male and females. So I should be able to divide 60 in half so it's equal. 2 divides into 6 3 times. 2 divides into 0 0 times. So I believe, or I surmise, the answer to be 30 birds were female. Can I see if it's reasonable? Well, I know 80 is the magic number. That's how many birds there were total. And I think there were 30 female, 30 male, because it's an equal amount, and 20 babies. So if I add all of these up, I should get that 80 to see if my answer makes sense. 3, 6, yeah, I got 80. So I know that 30 out of the 80 are female birds. All right, to make chocolate ice cream, yum, you need about 3/8 a pound of chocolate. How many pounds of chocolate will you need to make 4 batches of ice cream? Well, I want to make 4 batches. How much ice cream is needed for 4 batches? Okay, well, I need 3/8 a pound for every time I make some chocolate ice cream. But I don't want to make just 1 pound. I want to make 4. So what is 3/8 of 4? Okay, well, in order to solve this, I'm going to put my plan in action. And my plan is to multiply. I'm going to go ahead and times 3/8 times 4 over 1. If I put 4 as my numerator and 1 as the denominator, it doesn't change the value of my fraction. So 3 times 4 is 12. 8 times 1 is 8. I need to go ahead and simplify or make this fraction, this improper fraction, into a mixed number. How many times will 8 divide into 12? 1 time. I'm going to need to borrow. 12 subtract 8 is 4. There's 4/8. Now, can I go ahead and simplify 4/8? Absolutely. They share a factor of 4. So I can divide the numerator and the denominator by 4. And 4 divides into 4 1 time. 4 divides into 8 2 times. And it makes sense because 4 is half of 8. So 1.5. So if I go back to the original question, how many pounds of chocolate will I need to make batches of ice cream? Well, I understand the answer to be 1.5 pounds of chocolate are needed to make that ice cream. And I know it's reasonable because 1.5 pounds is equivalent to that improper fraction. It works. It's just another way to see it. All right, Bobcats, it's that time again. What did you learn? Well, I'm hoping today you got to practice some of those problem-solving strategies we've been working on. 1, did you understand the problem? Did you underline, circle some key important details? 2, were you able to answer the question? And then finally, could you check your answer to see if it's reasonable? Sometimes the best strategy is guess and check. Sometimes your plan might be drawing a diagram. Other times it could be multiplying fractions. But it's the same 4 skills. Understand the problem, make a plan, try it, see if it works, and if it's not reasonable, try something else. Thank you for your attention today. Have a great day, Bobcats.